Hi guys, this brings me to the last exercise of this chapter, which is basically a revision exercise which will have all the concepts that we've done till now. So let's look at this question. Question number 1 is homework for you. Question number 2 we already solved when we were solving exercise 17C. Question number 5 would also be homework for you. Question number 6 is also homework for you. So I start with question number 7. Okay, so let's look at this question. It says in O is the center of a circle with radius 20 centimeters. So the radius is 20 centimeter. OD is perpendicular to AB and AB is 32 centimeter. Find the length of CD. So let's join OA because that's the radius and see how this will help us move ahead. Okay, so number 1, join OA. Number 2, since OC is perpendicular to AB, therefore OC bisects AB. This is the property of the line joining the center of the circle to a chord, which we did on our first exercise. What this means is AC is equal to BC is equal to half of AB, and AB is given equal to 32, which means half of AB would be 16 centimeter. So AC is equal to 16 centimeter. Next, OA is equal to radius of the circle, which is 20 centimeter. Now let's see if I can apply Pythagoras theorem here. So in a right triangle OAC using Pythagoras theorem, what I get is 20 square is equal to 16 square plus OC square, which means OC would be equal to 20 square, that's 400. If I take this on this side, the 16 square, that's 256. 400 minus 256, that's 144. So this is 12 centimeter. So OC is equal to 12 centimeter. Next, OD is equal to OA is equal to OB is equal to 20 centimeter, which is radius which is given. Now I need to find the value of CD. Should be simple now. OD is equal to OC plus CD. In this case, OD is 20, OC we just calculated as 12 plus CD, which means CD is equal to 20 minus 12, that's 8 centimeter. That was the question. We've calculated CD. Let's look at the next question. The next question that I do with you would be question number 8. Let's look at the question. It says AB and CD are two equal chords of a circle, okay, with center O, right? If P is the midpoint of chord AB and Q is the midpoint of chord CD, and angle POQ is equal to 150 degree. So this angle in the middle here is given equal to 150 degree. We need to find angle APQ. Okay, so if this is 150, these two angles will be equal. Why will they be equal? Let's get into that. Okay, so number 1, since P is midpoint of AB, therefore OP is perpendicular to AB. Line joining the midpoint of a chord to the center is perpendicular to it. So this is perpendicular, which means angle APO is equal to angle BPO is equal to 90 degree. Good. Next part. So this is 90. Similarly, this will also be 90. Let's just write that. Number 3, since Q is midpoint of CD, therefore OQ is perpendicular to CD, which means angle QO is equal to angle DQO is equal to 90 degree. So this angle is also 90, this angle is 90. What we also know is AB is equal to CD, which means half of AB is equal to half of CD, which is equal to AP, which is equal to BP, which is equal to CQ, which is equal to DQ, which means all these four sides are equal. Okay. Since these two are equal chords, which means that their distance from the center of the circle is also equal. So since AB is equal to CD, therefore OP is equal to OQ, which means equal chords are equidistant from center. This is the property that we had done and proved in the first exercise, but we use this a lot in the second exercise, which means triangle OPQ is isosceles because OP and OQ are equal. What this means is angle OPQ is equal to angle OQP, which means in triangle OPQ, what I have is 150 degree plus 2 times angle OPQ is equal to 180 degree, which means angle OPQ is 180 minus 150, that's 30 degree upon 2, which is equal to 15 degree. So this small angle here is 15 degree, this small angle here is also 15 degree. Good, but what do we have to calculate? We need to calculate the length of or angle of ATQ, which is APQ. Okay, so angle APO is equal to angle APQ plus angle OPQ. This is visible. So angle APO is 90 degree. We calculated this in here, number 2 is equal to angle APQ plus angle OPQ, which is 15 degree. This is from 2 and 13, which means angle APQ is equal to 90 degree minus 15 degree, which is 75 degree. That's the question. We've already done that. Good, let's look at the next question. The next question that we do is question number 9. Question number 9 says AOC is the diameter of a circle with center O, and if arc AXB is half of arc BYC, we need to find angle BOC. So let's just write that down. Angle AOC is equal to 180 degree. Why? Since AOC is diameter, which means it's a straight line, which means the angle at the center is 180 degree. Next, since arc AXB is equal to half of arc BYC, which means the angle that they'll subtend at the center, which means angle AOB will be equal to half of angle BOC. Yes, so let angle, not 3, that will be number 4, 3 we've already done. Let angle AOB is equal to x degree, therefore angle BOC would be equal to 2x degree. Now angle AOC is equal to angle AOB plus angle BOC, which is 180 degree, is equal to x plus 2x, which means 3x is equal to 180 degree, which means x is equal to 60 degree. What do we have to calculate? BOC, which means angle BOC is equal to 2x is equal to 120 degree. That's the question. Done. Let's look at the last question of this exercise, which I'll do with you, which is question number 10, Very interesting question. It uses a bit of ratio proportion as well. So the circumference of a circle with center O is divided into three arcs, APB, which is my first arc here, next BQC and CRA. Okay, in such a manner that arc APB upon 2 is equal to arc BQC upon 3 is equal to arc CRA upon 4. So let arc APB upon 2 is equal to arc BQC upon 3 is equal to arc CRA upon 4 is equal to, let's say, a constant x, which we've been using the x method forever, which means arc APB is equal to 2x, arc BQC is equal to 3x, and arc CRA is equal to 4x. Now, since these arcs are in a certain ratio, which means the angle that they'll subtend at the center will also be in the same ratio, which means angle AOB would be equal to, let's say, 2x, a constant. Angle BOC would be equal to angle 3x, and angle COA or AOC, whichever we look at it, will be equal to 4x. And what will be the sum of all angles around a point? Yes, it will be 360. So 2x plus 3x plus 4x is equal to 360 degree. What this means is 9x is equal to 360 degree. Therefore, x is equal to 40 degree. Maybe I should take a different constant, because I have already taken x here. So I should take a different constant. My mistake here. I should have taken it earlier. I should have realized this earlier. Let me just erase this quickly. And let me take a different variable. So since these arcs are in this ratio, which means the angle that they'll subtend at the center will also be in the same ratio. So angle BOC would be in the ratio 3y, and angle COA would be 4y. Now the angle around the point would be 360 degree, which means the sum of these three angles will be equal to 316 degree, which means 9y is equal to 360 degree, which means y is equal to 40 degree. What do we have to calculate? Angle BOC. So angle BOC, let me not overwrite, angle BOC is equal to 3y is equal to 3 into 40 degree. Therefore, angle BOC is equal to 120 degree. That was the question. Done. That brings me to an end of this chapter. Before I leave, let me mark the homework questions for you from this exercise. Exercise 17D. Homework for you would be question number 1, question number 5, and question number 6. Thank you so much. Take care. Be safe. I'll see you with the next chapter. Bye bye.